Okay, hello everyone. Welcome to Concordia University's FORGione. Thank you for joining us for the next installment, really, in our ongoing series, taking a closer look behind the closed doors and into spaces that you might not know about across Concordia. And today, FORGione takes a closer look at the fORGione lab with Sarah Taylor. But to help situate you, first, we are streaming to YouTube, live from FORGione. We are located here on unceded Indigenous lands in Tiohtià:ke, Montreal. Here at FORGione, we work with our university community to help mobilize knowledge, co-creating daily activities that examine research questions, projects, things happening across the university. We're running this event as a live live stream off-site, and such as this, we may have some connectivity issues or maybe some problems popping up. That's part of the fun. Stick around with us as we work through this, and we welcome any comments or questions via the chat if you're joining us by Zoom. Those of you here in the space, if you have any questions, just let us know, raise your hand, and we'll try and get a microphone over to you a little bit later. Now, this is a bit of a special event also in terms of our Closer Look series, in that we're also taking a moment to kind of connect with the Sustainable Practices in Research project that's been happening, that both Sarah Taylor, who we'll meet in a minute, has been working on, with the coordinator from the Sustainability and Research, that's their title at the Office of Research, Brett Cox, who's joining us today. I'm going to pass it over to Brett to give us a bit of a background into the Sustainable Practices in Research project. Brett, it's great to have you.
Thank you so much, Doug. Working?
Oh, yeah.
Beautiful. Okay. Thank you so much, Doug. I appreciate that. Yes, my name is Brett Cox. I've been in this role as coordinator of sustainability in research since June 2023 now, leading various projects aiming to achieve the various strategies, targets, goals of Concordia's Sustainability and Research Action Plan. And specifically under Strategy 16 of the Action Plan, encourage projects designed to increase the sustainability of research at Concordia. This project to develop sustainable practices in research was brainstormed by mainly my supervisor, along with other members of the Sustainability and Research Action Committee, which involves various representatives from across the university. And the eventual goal, the dream, is that we are able to develop a guide for sustainable practices in any research context. But as an entry point to this goal, we decided to focus in on wet labs. My background specifically is social sciences, so in the immediate sense, it felt more practical because it's very hands-on in terms of looking at the research equipment that they're using. But as the project went along, I learned from Sarah and her other two colleagues in other labs that it's very, very complicated. So it's been a really interesting learning experience for me. But yes, the goal here, we were able to hire 3 different grad students in 3 different lab contexts to develop sustainable practices in their specific lab contexts. Yeah, it's been a really interesting journey so far. And with that, I'll pass it back to you, Doug.
Thanks for setting that up for us, Brett. So Brett, part of the I'll just talk to Brett a little bit while we sort that out, this is our first visit into a lab related to this program, but we're going to try to visit a couple other labs. And how did, maybe just if you could, I'm asking improv here, but a little bit of background into the project itself, like how it got started.
Yeah, I mean, going back to the work developed from the Sustainability and Research Action Committee, it really started from them. There was this overall goal of encouraging research projects to incorporate sustainability into their practices, was this overarching target.
Across all domains.
Across all domains, yeah, yes. Right. Yeah, so that's the original intention for this project. And I mean, once I started doing a bit of research into this area in general, sustainable practices in wet labs was a very common resource and tool that I've seen developed by many other universities. So with that, I'm like, okay, there's lots of examples. Let's start here as the most immediately accessible way to start this project off.
And how did I can see Sarah. You might be back. I'll wait for a cue from Birdie.
And can you hear us?
Yes, Birdie, I can hear you. How are we feeling over there?
Wonderful. Let's give it a try.
Sarah, while we have you, for as long as we have you, where are we? Could you give us a little introduction?
Yeah, so you hear me okay? They hear me, yeah? Okay. We're currently located in the hub facility at Concordia University's Loyla campus. So in this hub facility, there are a lot of different labs, including our lab, which is located on the 3rd floor. And should we, oh, and I guess, so I'm in my 2nd year of my master's degree, doing my master's degree in chemistry in Dr. fORGione's lab. And my project entails working on a medicinal chemistry project. Essentially, I synthesize compounds and working with the collaborating biology team, which are also at Concordia University. Once I synthesize my compounds, I submit it to the collaborating biology team. They test the compounds against liver cells, and essentially the goal of the project is to develop a library of compounds that can have good biological activity against liver cancer cells.
Let's take a look in the lab, and you can show us firsthand.
Right.
Yeah, let's go ahead. We'll take a minute for Isa, who's running our cams, to take a look around, see where we are here. Hello. Hi, Sarah.
Here we are in Sarah's lab, and as you and Brett were mentioning, I think what we'll look at first is the sustainability measures that you were talking about. Do you want to lead us into that?
Yep. So any typical organic chemical reaction that we do, essentially we first start by weighing out our starting materials, and I'll just give an example. So one of the features that we adapted following the sustainability project are the use of these glass weighing boats to substitute the use of these single-use disposable weighing sheets. The goal of this adaptation was essentially to reduce the amount of disposable weighing sheets that we were throwing out in our solid waste containers. So just starting off by tearing the weighing balance, I simply place my glass weighing boat on the balance, return my balance so that now it's at 0, and now I can weigh out my starting material conveniently inside the glass weighing boat. Now that I have weighed out my desired amount of starting material, typically what I would do is record my mass of starting material. And after I record my mass of starting material, I can now insert it inside my reaction flask. Now these glass weighing boats can be very easily cleaned using distilled water and acetone by using an appropriate waste container. Let's say this would be our aqueous waste. Just with a quick rinse of distilled water, followed by another rinse with acetone. These weighing boats can then be reused after drying, and again, minimizing the amount of the disposable weighing sheets going to the solid waste containers. So I would leave these just to dry, set aside, just so that someone can use it once it's dry. And my reaction flask here would be ready now to set on the hot plate. Another adaptation that we have in our lab following the sustainability project are the use of these ethylene glycol condensers to replace the use of the circulating water condensers. So before this adaptation in our lab, we used to use these circulating water condensers, which would be hooked up to the sink, and the sink would be continuously left on for the whole duration of the reaction, whether it would be a 2-hour, a 4-hour, or maybe a 16-hour reflux reaction. The purpose of the condenser being to condense any of the vapors inside your reaction mixture that might be evaporating, and to minimize any loss of starting materials and solvent.
Sarah, was that water was then lost? It wasn't circular.
Exactly. So in our facility, the sinks are not in its own water system. It is hooked up to the usual water system. And so, you know, that's just like hundreds of thousands of liters of water that would essentially just be circulated and wasted. And now with the use of these glycol condensers, we don't have to leave the tap on for this duration, for this long period of time.
Is that a typical lab practice that you've brought in, or was it something that needed to be developed in order to bring it into the lab here?
So conveniently, these glycol condensers were found commercially available online. There are other types of alternative condensers instead of these circulating water condensers, such as air condensers, which could also be applicable. We found that these static ethylene glycol condensers were just more affordable and seem to have better performance when compared to the air condensers, and they also have a similar performance to the water condensers. So essentially, they're not changing or affecting any experiment when you're changing from the water condenser to the static glycol condenser.
Okay, great. So it didn't really change how you work once it was installed. You could go about, okay.
If anything, it made it a lot more convenient. You don't have to deal with all of these tubes that are hooked up to the water sink, which could get in the way. Also, what happens sometimes is a tube might become disconnected, and if a person doesn't become aware, then their fume hood and the lab could flood. So now with these glycol condensers, because they contain a fixed amount of glycol, there's no need to have any tube connections, there's no risk of any water flooding. All you do is set your flask on your hot plate as you usually would, and simply place the condenser on top with a clip, and your reaction would be good to go without any concern for water flooding or any tubes in the way, and there would not be the sink of water left on for a long period of time.
Okay.
This is super nice, Sarah. And is there any downside to it at all? Maybe in terms of accessibility for other folks, in terms of getting them trained on how to properly use it and anything like that?
Perhaps one thing to note is that these glycol condensers are more expensive than these traditional water condensers, perhaps due to the limited production. Another thing to consider is that the glycol itself is a very greasy substance, and so one would want to avoid any type of spill or breaking of the condenser, which would result in a mess. Although the glycol itself can be cleaned up with an absorbent material, and then that material could be disposed of properly in a solid waste container through EHS at Concordia University. But other than that, these condensers are very simple to use. Once you fill them up with glycol, you don't need to empty them out. You can just leave them in your fume hood stored upright, and you would not have to refill it at any point. So as long as it's managed that way, then it's actually very easy and simple to use.
That's very nice.
Did you find that there were any other obstacles, like with the other measure that you had, or did everything go smoothly? Was it an easy transition overall, or are there other considerations you guys are looking forward to in the future when thinking about going sustainable?
Definitely, it's an ongoing discussion in our lab. Being an organic chemistry lab, we do produce a lot of waste, both solid waste and liquid waste through organic solvents and aqueous solvents. And I would say that one of the challenges possibly from these new adaptations that we have, when we clean our weighing boats, we do produce additional liquid waste. You know, when we use a bit of water to rinse out and a bit of acetone to rinse out, it does produce liquid waste. So now something to think about. Does the lab produce more waste by just using these single-use disposable weighing sheets, or does it produce more waste even though we use these glass weighing boats? Now we have to use a bit of solvent to clean them out, so we produce liquid waste. So something that we haven't measured ourselves but would be worth looking into. But that's one of the things, you know, with any sustainable initiative that we try to take is, you know, it's an ongoing discussion, and, you know, whether it's better or not, that's definitely something that we would have to look into, you know, just to keep in mind that we, you know, we don't have to adapt to something and think that that's the perfect solution. There might be a better solution. I believe that with these glass weighing boats, we are producing less of this solid waste, but we have to think about the additional liquid waste that we're producing and how we could maybe better manage that. Yeah, so in these containers, as you can see, we have this aqueous waste and the organic solvent waste. And so there is considerably a lot of waste that we produce. So.
Sarah, are there other practices or parts of the project that you would like to show us?
So nothing to show, but essentially things that we have discussed in our lab. We have talked a lot about acetone recycling. So anytime we're cleaning our glassware, typically we'll use like soap and sink water, followed by a rinse with distilled water, and then a final rinse with acetone, just to get rid of any maybe organic residues that might be left in our glassware. Something that we've talked about in the lab is reusing the acetone that we use to wash our glassware. When you think about it, it might just be like a little contaminated with water, but if you're just reusing that acetone that just might be a bit wet, it wouldn't necessarily affect your glassware afterwards if you leave it to dry for a proper amount of time. So that's one thing that we've talked a lot about in our lab, to just try and, you know, take another step in reducing the amount of waste we produce. And another thing that we've discussed is reusing the glass test tubes after column chromatography. So typically what we do after running a column, let's say we fill up a rack with a lot of compounds and organic solvent, maybe 50 tubes for instance, and we know our compound is in tube 25 to 35. What we usually do is that we take each tube, we'll rinse out to transfer our compound into a larger flask to then evaporate off all the solvent. But each time we rinse these tubes, essentially we're almost cleaning these tubes when we think about it, because we rinse it enough times to make sure that we've transferred out all of our compound. What we were doing essentially is that after rinsing out these tubes, we would simply dispose of them in our glass waste container, and it becomes glass waste. But what we talked about, instead of throwing it out after we've rinsed that out a few times, why not reuse these tubes? Because essentially we've rinsed out everything already. They can be considered to be clean. So that's something that's ongoing in between members. You know, there is a lot of things to think about, you know, when taking these steps, is that, you know, after running a column, you don't want to risk recontaminating what you've already spent a lot of time and resources on trying to purify. So it's just something to think about for anybody who's trying to, you know, minimize the amount of glass waste using this method, is that as long as you're taking the steps to make sure that these tubes are actually clean and rinsed, if you do plan on reusing them, then you don't risk contaminating something else afterwards, which would still end up leading you to use a lot of resources. So.
Wonderful. Thank you so much for showing us these new sort of sustainability measures. I'm wondering what it is that these measures are in service of, and what it is that you're doing day to day here in the lab.
So I myself, I do try to use the weighing boats every time I try to set up a reaction. One limitation that I've found is that there's not every compound that can be weighed out using these weighing boats. Sometimes you are weighing out like large crystalline material, which simply would not fit through that little exit spout when you try to transfer it to your reaction flask. so I do end up still using the weighing sheets. But it's about minimizing the amount of weighing sheets, in this case, that one would use. So it's not a perfect solution. I'm not able to use maybe the weighing boat for every starting material that I weigh out. But if I'm able to reduce the amount of weighing sheets that I use, then essentially I would be reducing the amount of solid waste being produced. And then for the condensers, any reaction that necessitates reflux, we always, as a group, we all use the glycol condensers. There's nobody that uses the water condensers anymore, just because it's a lot more convenient, and also now we don't have to have just the water continuously running, so we reduce a lot of the water waste.
And Sarah, does everyone here in the lab, are you all working towards the same purpose, or do you have an individual focus?
So we are all working on different projects. There are some people who are working on medicinal chemistry projects, whereas there are other members of the lab who are working on other projects, maybe more related to materials chemistry. In the past, we've also had individuals working on green chemistry projects, but we all talk to each other. Even if we are working on different projects, we all talk to each other about what we're working on, just because that's the type of environment that we have built in this lab. Being in an organic chemistry lab, you can run into so many different issues, challenges, and questions, and talking to each other about them is really what helps us sort of troubleshoot these things together. And it might help another individual, if ever they run into that kind of issue, they'll remember the discussion that they had with their colleague, and it just helps all of us, progress on our own projects. And we create this collaborative environment, even if we're all working on different things.
And what is the product that you're working on specifically?
So I myself, I'm not working on one target product, but I'm trying to develop a library of compounds. Essentially, the goal of the project would be definitely to find one molecule that has the best biological activity against the liver cancer cells, a potential drug-like molecule.
So you're working with liver cancer specifically?
Yeah, exactly. We're targeting liver cancer cells.
That's fascinating. Is there any other equipment that we could take a look at that you use in the day-to-day? I understand that these are the sustainable processes that you've shown us.
Yeah.
But is there other equipment we could take a look at as we walk around?
Yeah, definitely. We can look at the other room with all of our equipment. Perfect.
That's sort of part of the fun for this, Sarah, is to be able to see inside, see what's happening in some of these spaces we don't get access to, and just kind of see more what your day-to-day work is like.
So where are we headed now?
Really quickly, we have our freezer room, which a lot of our sensitive materials would be stored in.
Hard time hearing here, but thank you for continuing.
Just a quick peek, we do have a -80 freezer shared with other labs, as well as some -25 freezers. And in this room we have some other equipment, some shared equipment, as well as some equipment of our own. The equipment that we use a lot is our gas chromatography mass spectrometry, our GCMS. So one of the things that we do when we synthesize a compound is we'd like to find out whether we actually made the right compound or not.
I'll hold you there. We recorded all that. That's great. We lost contact, so we'll go back to the
Okay.
lab.
So we won't talk about.
That's okay.
Okay.
What we'll do is we'll go back. We'll say they'll be like, oh, we can hear you.
If you
again.
want, I have some spectra that I can show just to say this is what it looks like when it's messy after you make the reaction, and then when you purify it.
Beautiful. Let's do that.
Okay.
I'll tell you when we're back. We're
All right.
connecting. It's okay. We thought we were going to lose. No problem.
Developing that particular lab. It'll be curious to see in the other labs when we get to those if they're similar in terms of, this one seemed to be more focused in terms of waste, managing some of the waste that was being produced.
So force-based team, I think we might be back. We lost you there. We were in the room for a little bit.
I was just chatting with Brett about some of the things we had just seen. Just gave us a moment.
Wonderful. So we're back here in Sarah's lab where we started off, and I think she's just going to show us one last product.
Yeah. So as an example, when you finish a reaction, obviously the product, you make something, maybe you make your target product, but you might have some other things that were made, you might have leftover starting materials, and it might look really nasty, sometimes like a black gunk of sorts. Even the spectra, when we analyze our crude compounds, so the way we analyze our crudes is using our nuclear magnetic resonance spectroscopy, so our NMR. We'll use either proton NMR or carbon NMR. We also have our gas chromatography mass spectrometer, GCMS, essentially, which can help us identify what compounds might be present in our mixture based on their unique fragmentation patterns. So I have an example on my laptop if you want to see. Now bear with me, I'm just trying to find a more cleaner. So in a typical crude GCMS, you would have a lot of different spots, but the whole point would be to try and figure out maybe one of the peaks might correspond to the target molecule. And if I see that in one of the peaks, I have the mass that corresponds to my target compound, I can also confirm that by looking at its unique fragmentation pattern, which might give me more idea into the confirmation of the compound that I made. We also look at NMR, as mentioned before. So in a crude NMR, it would look really messy like this. Sometimes it's hard to actually confirm whether your compound was made or not just by looking at a crude NMR, which is why we'll use other methods of analysis just like the GCMS. But after purifying the compound, which could either be done through recrystallization or column chromatography, you end up with a much cleaner spectra of something that you could actually characterize and analyze and determine whether you've actually made that final product or not. So you can see here, there are less peaks, but after I would analyze them, I would be able to confirm that my product has actually been made. And even with the GCMS, we are left with one peak only when we have a pure NMR. And again, just by looking at the unique fragmentation pattern, we would be able to further confirm that that's the actual compound that we've made. And the best part is that obviously your final compound will look a lot more clean as well.
Sarah, you're currently doing your master's. I'm always interested to know how you what was your path that led you to this type of work?
I've always been very interested in medicinal chemistry and pharmaceuticals, and I'm very happy that I ended up with this project, especially working towards cancer research and looking for a treatment for liver cancer. Coming from a family where my mother was a nurse and my father was a paramedic and my sister is also a nurse, there was always a lot of medical talk at the table, but I've always been very interested in ways of helping people, and I've also always held an interest for chemistry. So I found that middle ground. One of those middle grounds was medicinal chemistry. So working with medicinal chemistry really, shows me that there's a lot that can be done. There's a lot of work that can be done in cancer research and the development of new drugs. And that's something that definitely piques my interest.
That's great. Brett, do you have any last questions? I think before we wrap up and say goodbye to Sarah.
The only thing that comes to mind is general things. I know there was the specific equipment that you bought, like the waterless condenser and the boats, but other more general things like proper maintenance of the freezer, closing the fume hood, is that things that you have noticed being a bit more regular in the lab, or it just kind of depends on the person?
Honestly, I think that's what's important of always having discussions with your group members and your colleagues. You know, there might be a week where once we talk about it, especially following up on that sustainability project, you know, the energy was high, okay, let's do better, let's close our fume hoods, let's clean the freezer more. And you know, as time passes, you know, we get busy, we might forget about these things. So I found that, you know, in our group meetings with all of our lab members, keeping up these conversations, just letting people know, hey, you know, last person leaving the lab, just have a quick look around, lower everybody's fume hood. Let's have a quick look at the freezer door, maybe scrape off any of the dry ice. Continuously having these discussions is very important just because, you know, we're human, we can forget, but it doesn't mean that, you know, if we mention it once that we've done our job and we don't ever have to talk about it again. So I think it's important just, you know, hold ourselves accountable, but we're all in this together. So, you know, if you notice a colleague maybe has forgotten something, it's all about just talking about it as a group, like, you know, hey guys, just as a reminder, like, let's keep doing this just because it's better. And as long as we keep having these discussions, people will keep remembering and maybe pass along the message to other labs as well.
I really appreciate those themes of accountability, collectivity, and communication. Thank you, Sarah. That was great.
Yeah, it really came through the idea of this ongoing conversation, because it's also a kind of a teaching lab as well. So the idea that you're kind of on not even just establishing these practices, but actually just talking about what they could even be going forward, I think that must have a longer impact and sort of ongoing development. Sarah, thank you so much for doing this with us. We're going to wrap up from here at FORSpace, but just wanted to let everyone know that this conversation does remain on our YouTube channel if anyone would like to revisit it later. Also want to thank Brett for joining us here. We look forward to seeing some other labs coming up in the future. Sarah, thanks again. Bye from FORSpace. Thanks, FORSpace team. All right, have a great afternoon.